All right, now we've gotten down to the section where it talks about examples A and B. It says the product and quotient properties of exponents can be used to simplify expressions. I'm going to kind of just go over the steps and talk through the steps on what they did here in example A and B, but I'm not actually going to do it in detail because we're going to just dive into the try these here in just a second. The first thing that they did whenever they're multiplying numbers that have like with exponents and stuff, we're going to simplify this expression. We're going to first group our powers with same bases. Group your powers with same bases. So notice our coefficients, the 2 and the 5, went out to the front, and we have grouped the x's here. Now, we're going to apply the product of property. The power of product. No, product of power. I think I said it. I don't know. There are too many P's here. The product of powers property. There we go. Okay. Well, 2 times 5 is just 10. And remember, when you apply the product rule, we add our exponents. So 5 and 4 is going to equal 9. So you simplify your exponent by adding the two numbers together and getting a final answer of 10x to the 9th power. Let's take a look at B. B, you can do the same thing, but with quotients, so division. Same way it applies, same rules. Group your powers with your same bases, okay? So they did the 2, they grouped the x's in a fraction, they grouped the y's in a fraction. Then they applied that quotient of powers property, where we subtracted our exponents and then simplified them. So they got 2x to the 4th, y to the 2nd. Like I said, we're just going to dive on in here. We're going to work through A, B, and C here. I'm going to actually work this on a separate sheet of paper so I have more room so you can kind of see my method to the madness, okay? So, A. A says, take 4x, y to the 4th power. We're going to take negative 2, x squared, y to the 5th power. And we're going to multiply these together. So we're putting like bases together. So we're going to do our grouping part now. So we group our coefficients. 4 times negative 2. All right. Then next is going to come our x's. X times x squared. And then we got y4 times y to the 5th. Now, first off, I see an x, but I see no exponent. That is not a 0. If there is no exponent there, there's only one x. So we could note it with an imaginary 1, okay? So we're going to put our 1 as our exponent here. Now, 4 times negative 2 is negative 8, right? We're applying our product rules, right? So we're going to add our exponents here, 1 and 2. I cannot add 4 and 5 because those are a different base, okay? So only like bases. And now we'll add our 4 and 5. I got negative 8 x to the 3rd, y to the 9th power. Because 1 plus 2 is 3, 4 plus 5 is 9. Please remember to write this 1, otherwise you would have written down x squared here, and that would have been the wrong answer. So definitely make sure that you put your exponent there. If there's no exponent, it's an imaginary 1. Negative 8 x cubed y to the 9th. Let's take a look at that B now. B. We're going to do 2 over, well, I should have written the whole top, I'm sorry. That should have been 2a squared, ooh, gotta see, b to the 5th c, okay? And we have a b squared c. So we're going to group together. Oops, I shouldn't have put this here. I didn't want to put it here. Sorry. I want to go down. We're going to do 2 over 4. Those are like, because they're our coefficients. We're going to multiply. We have a squared divided by a. We're going to multiply. We got b to the 5th power over b squared. We're going to multiply c divided by c. Okay? Now, we're applying our rules, but before I can do that, I see a whole bunch of letters with no exponents. So we're going to go use our imaginary rule of thumb here. 1, 1, 1. Okay? So 2 divided by 4 is not 2. It is not 2. Please don't put 2. 2 divided by 4 is 1/2. So 1/2. We're going to do, remember that we're dividing, so we're actually subtracting those exponents. So 2 minus 1. We're dividing again, so we're going to subtract those exponents. 5 minus 2. And again, we've got this division, so that's c, 1 minus 1. So I'm going to write this all in the numerator position, okay? This is a to the 1 power, b to the 3rd power, and c to the 0 power, but 2 is still in that denominator position. You could have written it like this, 1/2, and just done a1, b cubed, c0. That's the same as well. That I would have accepted either one here. And the last thing I want to warn you about, okay? Remember earlier we could say, okay, if it didn't have the exponent, it was a 1. So sometimes you might not see this 1 written because it's understood to be a 1 if there's no number there. But you cannot just take off the 0 here. If there is a 0 power, that means that this answer actually goes to 1. Or the c's would have canceled out because c divided by c is 1. So you would have ultimately probably seen this answer after you're taught all of your rules. You would have seen this as 1/2 a b cubed. The 1 wouldn't be there because they wouldn't write the understood 1 there. And because c was to the 0 power, it's actually simplified to 1. It's like saying 4 divided by 4 is 1. Well, multiplying by 1 doesn't change the number, so usually you won't write it. But that gets deep into some rules that we will not learn until later today and tomorrow, okay? So don't fret on that. If you wrote it this way, I would have accepted it just fine, okay? 1/2, I'm going to put a to the 1st power, b to the 3rd power, and c to the 0 power, because that's technically what we learned today in this lesson, okay? Let's take a look at that c. I see a lot of things going on here in c. I see multiplication and division. Ooh, that's going to get a little tricky. That's 6y cubed divided by 18x times 2xy. Oh boy, we got a lot going on here. I don't even know how to handle this. Okay. The first thing I think I'm going to do, just to kind of keep myself here, is to make these two separate fractions. Okay. And to make this second part a fraction, I would just do divided by 1. Okay. So I'm going to first do that so I can kind of deal with that mess in itself. So we got 18x times 2xy over 1. Now, remember that when we're multiplying numbers, fractions together, the denominators do not have to be the same. Okay, so I can multiply these just as they are. So what we're going to do is we're going to take 6y cubed and we're going to multiply it by 2xy. Okay, and then we're going to take that and divide by, well, 18x times 1 is 18x. Okay. So now I at least have it all in one like fraction form here, so I can kind of separate it into pieces. Now I have to kind of write here off to the side, so I'm going to draw myself a little arrow to make a note that we're going to kind of move up here so I can have enough room to kind of finish this problem out. All right, so we're going to put our 6, our 2, and our 18 all together. So that's going to be 6 times 2 divided by 18 times. We have a y cubed and a y, right? But there's no y in the bottom. So we won't write a denominator there, okay? And then I have an x and an x on opposite sides of the fraction bar. All right, I see some variables with no exponents. Let's go fill in our imaginary ones. So 1, 1, 1. Got it. Gonna do a little bit here. We've got 6 times 2 is 12. 12 divided by 18. We'll come back to that. I want to simplify that in a minute, but I'm not ready just yet. Okay. Gonna apply this property. Well, these are multiplied, so we're gonna add those exponents. So y cubed plus 1. Now we have exponents, but they're dividing the numbers, so we're going to subtract those exponents. Let's take a look at what we got. Now, I don't like this 12 over 18. We're going to come back to this in just a second, but let's clean up. The y is going to be raised to the 4th power, and x is going to be raised to the 0 power. We'll get into that really in the next lesson and dive into that whole 0 power in a little bit. So I'm not going to worry about it just yet. I'm going to actually just leave it there, okay? But I do want to talk about this 12 over 18. I want to simplify that. What number can actually divide into both 12 and 18? I think that 2 is a good number. Well, I'm going to divide both of those by 2. 12 divided by 2 is 6. 18 divided by 2 is 9. Now, I know that 2 can't go into both of these numbers, but I do notice that they are both divisible by 3. So 6 divided by 3 is 2. And 9 divided by 3 is 3. So whenever I actually simplify that equation down, this fraction down, it actually reduces to 2/3. So it's 2/3 y to the 4th, x to the 0. If you like to write it in alphabetical order, you can switch those because they're being multiplied together, and we've got the commutative property. So, got 2/3 y to the 4th, x to the 0. That is the wrap-up of this lesson. On the next slide, you're going to see some matching of your vocabulary. Hopefully you get them all right.